Hello and welcome. Today we are adding equations. We are doing that because it is a method for finding the solution for a system of two linear equations. So our objective for today, we just have one, to learn one method for solving systems of two linear equations. I've highlighted one because there are several. Sometimes this one is going to be the easiest one. So let's look at a system of linear equations. These two equations are linear because both of them make lines. And these are the lines that they make. Well, that black dot there right in the middle, that is the solution. That is where both of those line up. So x can equal 2, y can equal 1, and both of those will be true. That's the intersection of those two lines. Vocabulary terms we need to go over. The y-intercept. That is where a line crosses the y-axis, is also where x equals 0. So let's look at a picture of that really quickly. Remember, this is the x-axis. We always deal with that one first. That's the first variable or coordinate we get. Second coordinate listed is always the y-axis. The y-intercept, this is the y-axis. The y-intercept is where it hits right there. So we can see that the y-intercept in this case is 2. Slope-intercept form is a related idea. This is slope-intercept form, y equals mx plus b. Let's break that apart and see what it looks like. Here we have a similar one to what we just saw. This is the y-intercept right here. That means that m is the slope. And so this slope is positive. It goes the direction we read, like we're walking uphill. So that's a positive slope. And it looks like it's just a little bit less than 1. So this number might be 0.9 or 0.8 or something like that, because this slope isn't really that steep. A slope that is over 1, if m is over 1, maybe it's 2, that's going to be a really steep slope, something like that. Okay, and so again, b is the y-intercept. So b in this case would equal 2. And that's where when x equals 0. Parallel lines. Lines that do not intersect are parallel lines. So we know that railroad tracks never intersect. If they do, that's a problem. Least common multiple. Let's look at some examples. Least common multiple between 2 and 4. Well, let's think of both of those numbers. Let's look at 2 first. Multiples of 2 are 2, 4, 6, 8. We know those. And then multiples of 4, 4, 8, 12, 16. Well, we can already tell that 4 is the least common multiple between them. And so part of that's really easy because 2 divides 4. So that's the easiest case to find. Here's one that's also pretty easy, 2 and 3. Because we can always find a common multiple by multiplying those two numbers together. We do that, we get 6. And that's also the least common multiple in this case, and it's a common multiple. So we can always multiply them and get 6. We could do that with 4 and 6. We could multiply 4 and 6, we get 24. However, that's not the LCM. That's not the least common multiple. The least common multiple between them is 12. Okay, be sure to line up the like terms. When we are adding equations, we're going to line up the like terms. So here we have an equation for a line, an equation for a line. But here we have the y term first. Here we have the x term first. Let's just use the commutative property of multiplication and just switch one of those around. So we switch the top around. Now we have the x first and the y later. So that works. Okay, once we have done that, we need to make sure that adding them is going to do something useful for us. And what we want is to eliminate one of the variables. If we add a 2x, or this is a positive, if we add a 2y and a negative 2y, really what we're doing is we're subtracting it from itself. That's what we want, because this y term is going to disappear, and then we're going to be able to solve the system of equations. So when we add those up, we know that those are going to disappear. These just add like normal. These are like terms. The 3x and the 3x gives us 6x. And then these add like normal, but really they subtract, don't they? Because really what we're saying is 7 minus 1. But remember in algebra, adding and subtracting are really the same function. So 6x equals x. Well, we know that x is going to equal 1. But now we find the y term by using the x term. So we're going to use the value of x to find the value of y. We do that by taking the x and putting it in one of those equations. It doesn't matter which one. Let's just use the first one. So instead of x, we're going to have 1 there. Now we have 3 times 1 plus 2y equals 7. We're going to use the order of operations. Going to multiply 3 times 1. We get 3 plus 2y equals 7. We're going to get y by itself by subtracting 3 from both sides. We do that, and these cancel. We know they're going to cancel. 2y equals 4. Well, we know that y is going to be 2 because 2 times 2 equals 4. So now we have the y term. Remember, we're always going to write it this way, and I've seen students get confused at this point. The x term always goes first, it's alphabetical, and then the y term goes later. So make sure you're always writing the coordinates that way, with a comma in between them. You got to have that comma. Okay, this is what it looks like when you graph it. This is the first line. The red line is the first line. I don't know why the red always goes first, but it does. And then the second line is the blue line. And of course, these coordinates are where they match up. So it's 1 over and then 2 up. I think this is a different one. I don't think it's the same one. Well, that looks like 2, but that doesn't look like 1 to me. Looks like it's away from 1. Anyway, we are going to match a positive term with a negative term. That is something else we have to do. In the last one, that was done for us. In this one, it's not, because this is a positive y, this is a positive y. Well, let's say the bottom one. That one's easier for me. The bottom one is the one we're going to make a negative, so it looks like a traditional subtraction problem. And then we're going to do that by just multiplying both sides of that equation by negative 1. As long as we do it to both sides, we're okay. But really, you don't have to do that. Let's go back to where we were. When we multiply something times negative 1, like I just showed you, all we're doing is we're changing all the signs. So this imaginary positive sign, we're going to make it negative. We're going to make that negative, and we're going to make that negative. And here's what that looks like. Negative, negative, negative. All of them become negative. Now we can add these two equations, and we know that the y terms are going to cancel out. And over here, the 4x and the negative 2x gives us 2x. The 9 and the negative 5 gives us 4. Well, 2 times a number equals 4. We know that x is going to equal 2. And then we're going to use that x term, 2, to find the y term. So sometimes what I do when I write this out for myself is I write the parentheses, I write the x term, and then I leave a blank for the y term, or the y term. I leave a blank for the y term because I don't know what that's going to be. Okay, so we use the x term, find the value of y. I'm plugging, go back to where we were. I'm going to put the 2 in for x in this first equation. I could use the second one. I'm going to use the first one, so this one's got all the negatives in it. And when I do that, order of operations tells us we're going to deal with the 4 and the 2. That's going to give us 8. 8 plus y equals 9. Well, 8 plus a number is 9. We know that y is going to equal 1. So now we have the whole thing. Let's see how that's graphed. So here we have 2 over and 1 up. Looks like the solution to that problem. Okay, what if this is in a different form? This is in slope-intercept form, and we're going to look at y. However, they all match up. The y terms are on top of each other, the x terms are on top of each other, and then the regular old numbers are on top of each other. We can add that equation still, but it is in slope-intercept form. Both variables get canceled out because the y is going to get canceled out and the 3 is going to get canceled out, the 3x, and that's after we have multiplied the bottom equation times a negative 1. We get 0 equals 1. Well, of course, that's not right. 0 does not equal 1. The answer is that these lines are parallel lines. So they do not match Just like the railroad tracks, there is no place that they intersect. These are parallel lines too, incidentally. So there is no solution for that. And when you don't always have to get 0 does not equal 1. It could be any number. It could be 0 does not equal 2. I think it could also be like 0 does not equal 2, or 1 does not equal 2. But that's probably what is happening. You probably have parallel lines. Okay, so slope-intercept form. We're just going to review this because when we have something simplified that way, y by itself without a coefficient in front of it, and then we have the x term, and then we have the regular old number, this tells us the slope. Well, if this slope and this slope are the same, then we know that we have parallel lines. Again, just like these lines, the slope is the same on them. They cannot intersect each other. So that might be a reason to keep it in slope-intercept form, but really you don't have to bother with that because you'll find out the answer anyway. Okay, what if we have to double the number? Let's go back to this one. We're going to make one of these terms a negative term so that we can get rid of it. We do have fractions here. I haven't been dealing with fractions in this because it's so hard to show that on a PowerPoint presentation, but we do have them sometimes. And so to line up some negative terms, we're going to, or to make them the same, I'm sorry, to make these the same, we're going to double this equation so that we have a 4x here and a 4x down here. And when we do that, we'll find that we have identical equations. Now, when I did that, I did not multiply times a -2, which we would normally do. I did that on purpose because I want to show you that they are identical equations. Well, if they are identical equations, these two equations represent the same line. So even though they are different equations here, they are ultimately the same equation. So they would also not have a solution. Okay, so back to something that does have a solution. We want to make sure that we take the path of least resistance, that we do this the easiest way. And that's kind of a relative thing because what's easier for you may not be easier for me. I'm looking at this and I'm seeing two possibilities. I could deal with the 9 and the 3, or I can deal with the imaginary 1 here and the 2. Well, these are lower numbers, so as a rule, I'm going to go with the lower numbers, the easier numbers. So we're going to multiply this top times a -2 so that these terms can cancel each other out. So when we multiply this whole side by -2, this whole side by -2, this is the new equation that we get. Now we have these aligned so that they're ready to cancel each other out, and we're going to be left with these terms. So those cancel. The -18y and the -3y become -21y, and then over here, the -22 and the +1, we get -21. Y is definitely going to equal 1. A number times itself will be the same number. Okay, so now we use the y term to find the x term. So we found this one first. So when I write this down for myself, I write the parentheses, I write a 1, and then I leave a blank here for the x term. And we'll find that later. Okay, this is the same system of equations that we just looked at. Maybe you're looking at it and you say, you know, the y terms aren't so bad. We're just going to triple this bottom equation because it's already negative. So if that is what occurs to you, and that's what jumps out to you, go ahead and do it that way. That's totally fine. You'll get the same solution. Okay, still taking the path of least resistance. Now, the easier solution or the easier way to solve it stands out a little bit better. The 7 and the 5, the least common multiple between them, we know it's going to be pretty high. It's going to be 35. But the least common multiple between the 3 and the 2 is going to be a lot easier. We did this at the beginning. We know that the least common multiple between 3 and 2 is going to be 6. And we can always find a common multiple by multiplying the two numbers together. If we multiply 3 times 2, we get 6. We multiply 7 times 5, we get 35. That is a common multiple, and any common multiple will work for adding the two equations together. But in this case, we have to remember that we are going to make them the same. So we can't just take one of these and double it, and we can't just take one of them and triple it. We have to actually deal with both equations. In this case, we're going to double the first one, triple the second one. So we have to do two things, and we haven't had to do that before. So we found the common multiple, which is 6. And to get this one to 6, we're going to multiply it times a positive 2. This one, remember, we want it to be negative 6, so it cancels out more easily. And so we're going to multiply the whole bottom equation. That's supposed to be a negative 3 there. We're going to multiply the whole thing times negative 3. Okay, now the negative 3 is there. Now it's correct. Okay, when we do that, we're going to use the distributive property. So the 2 times the 3x will give us 6x. 2 times the negative 17y gives us negative 14y. 2 times the negative 5 gives us the negative 10. We do the same thing to the bottom, but again we're using the negative 3, and then they line up. These x terms are ready to be canceled out. The other terms are going to go along for the ride. When we cancel those two terms out, we're left with this. 15y and the negative 14 become a positive 1y. That's an imaginary one. And then we subtract 10 from 12, we get 2. Y equals 2. We're going to use the y term to figure out the x. And the solution will be 3 and 2. Those are the coordinates that solve that line. And that's what it looks like. Those two lines have very similar slopes. They're very similar lines. Okay. Here we have options again. We can eliminate the x terms. We can eliminate the y terms. I'm looking at the x terms and I'm thinking, I don't want to deal with the 7 and the 9 because we're going to have to multiply them by each other, and that's going to be pretty high. If we multiply this whole thing times 9, this whole thing's times 7, it's going to get pretty squirrely. The 4 and the 6 are going to work a lot better, but we don't want to just multiply them together because 24 is what we get. That's the product. And 24 is kind of high. We want to make sure we have the least common multiple. So remember, the multiples of 4 would be 4, 8, 12, 16. Multiples of 6 would be 6, 12, 18. Well, 12 is the least common multiple between them before we get to 24. So we want to make sure that we use 12 just to make it easier for us. Incidentally, if we used 24, we would still get the right answer, but we would be taking a longer route to get there. All right. So to make the 4 into a 12, we're going to multiply it times 3. To make the 6 into a negative 12, so it cancels, we're going to multiply it times a negative 2. So we got to do the whole top, we got to do the whole bottom. And when we do that, when we do the distributive property, this is the new equation that we get, same at the bottom. And I won't go through that because I went through it before. But they are ready to add up now because these terms are all lined up. The 21x and the negative 18y give us a 3x. Over here we get a negative 3. Well, 3 times a number is negative, so it's going to be a negative 1. We multiply something times a negative 1, it turns out negative. So x equals negative 1, and we're going to use that x term to find y, and when we do that, we will find that y equals 3. Did we meet our objective for today? We just had one objective. Yes, we did. We just learned a new way to find the solution for a system of 2 linear equations. Thank you. Let me know if you have any questions.